Buenas noches. Okay, welcome everybody.
Good morning, Professor.
Okay, let's start with the book, and then maybe we'll do something else too. But does anybody have any questions about the homework, the practice problems and the reading?
I don't know how to solve some of the questions, Professor.
You don't know how to solve which one?
For example, let me check again. But I think it's some questions in chapter 3.
Chapter 3, okay. All right. Let me look at that too. Okay, I'll just go quickly, just see if there's anything that we need to mention in the chapters quickly. So I'll just open up our studio also, and I'll share my screen. Okay. Okay, so we have this, and okay. So let's just go through some of the text now. So you already went through swirl. So a lot of this is just a review of swirl. So I think everybody understands how to write a basic function. And by the way, this can be a useful function also. Actually, systime can be useful for determining how quickly your code is running. What you can do is you can run some code, like do a loop, and you're wondering how quickly it performs. You can run systime, and then at the end run systime, and you can set systime to a variable at the beginning and at the end, and then subtract them, and you can determine how long it took you to run that code, and then you can compare with the other code to see how quickly the code is running, or which version is running more quickly. Was that clear? Everyone understand that?
Yes.
So I guess we could try it here. So let's suppose we have system time, and set that equal to beginning. And then we have, okay, so somebody tell me the code for, let's say I want to go through let's say I want to go through a loop and just add up all the elements in a list. Can somebody tell me that? How to do that? I want to add all elements of a list. let's say I have a list, let's say not a list, let's say a vector, v equals, let's say 1 to 1000. How do I add up all of those numbers? Anybody want to give me the code for that? No? For what?
For I in V.
For I in V?
Colon.
What?
I don't know.
No, colon is for
Yeah.
Python.
I realized.
Yeah.
Curly bracket, is it?
Right, that's right. Curly bracket. So maybe, you know, might be interesting. Wait, that's not right, is it? It's not right. I think it's just for V. No, how's that one? Something's wrong with that. Let's see.
Oh, you have to put the I in V in bracket.
Right.
Yeah,
That's right. Then, okay, what? Sum equals 0. So I guess we have to do this.
Sum equal to B plus sum.
What?
Sum equal to I plus sum.
Say that again? Oh, I plus sum, right. Okay, let's see, does that work? No. What's wrong with it now? Okay, I forget already. Let's look it up. Let's look up 4. For that, and that looks right. That's nice. I didn't know we'd get that. For a variable in vector. So this should be okay for that. Sum equals I plus sum.
Oh. I think it doesn't do equal, right? I mean, in R.
No, it does equal.
Oh, it does.
Yeah. Oh, that's not it. By the way, anybody know the shortcut for this thing? Oh, maybe it should do equal, but it didn't want to. Maybe you're right. Okay, anyway, anybody know the shortcut for this? There's a shortcut for this. It's like, let's see, is it this? I'm going to try. I think it might be Alt arrow. No, that's not it. Alt arrow, no. What is it? Let's see. Let's just look that up. I've forgotten already. Let's look up shortcut for arrow in R. So let's see. This is in our studio, I guess. Alt plus. Maybe that's it. Let's try that. Let's just try it. Alt plus. No. What is it? Alt? No. What is it? I used to know it, but I forget now. I use Alt plus, Alt plus at, oh, that's it. Alt plus underscore. Yeah. Okay. So just in case you want to do that, it's Alt. I'm hitting the holding the Alt key and then underscore gives you that. Okay. Yeah, you're right. Actually, I guess it doesn't take equals inside the for loop. I don't remember that, but I guess that's true. No, it's working. Oh, maybe it was just slow. Seems like my RStudio is slow, so it didn't catch on that I had finished it. Because now it's working. Okay, but anyway, if we wanted to be really our style, we would do Alt arrow like that. Okay, so now we have that. And then we can run n equals okay, and then we can do n minus beginning. Okay, now let's run the whole thing. Something's wrong. Okay, let's try again. We need an expression to be timed. Okay, let me check this a little bit further. Let's go. Here, let's look at this. So it's supposed to work, but it's maybe maybe I have to use systime. Let's try that. Systime. Let me try it that way. Okay, there. Okay, so we're gonna see that. It's interesting. It gave this print. Why did I didn't expect it to give this. End minus beginning automatically threw this in. I guess this time must give a certain kind of object out. It's not just time. It must be. It's not just a number. Let's see. What is sys time? So let's try sys time. Okay. So let's see. So if we go down to yeah, here. So how many people have used Python? Or let me ask it another way. Is there anybody who hasn't studied Python? Is there anybody who has not studied Python? Okay, so does everybody know what we mean by objects? Oh, somebody didn't. on, wait, who didn't study Python? Is it? Okay. So have you studied any programming? Tran-san, have you studied any programming?
Yes, Professor.
So do you know what we mean by an object or classes?
Yes.
Okay, good. All right, so that's all I meant. So we all know what objects are, right? Does everyone know what we mean by classes and objects? Okay, so then systime, if you want to know about in R how to use the help, so you want to know what it returns, what kind of thing you get out of this systime function. You look at the value. The value is what's returned by the function. That's similar to in mathematics when we say, let's say we say y equals f equals x. How do I do it? X squared plus 6, right? So that's a function, right? And we would write it like y equals some function of x, right? Does everyone agree with that? Okay, so we say, what's the value of the function? We mean what gets output from that function. So we use that language in math also. And when we're talking about a function in R, the value of the function is what gets returned by the function. So what gets output from the function. So this, I didn't realize what gets output by this is some kind of special object. I thought it was just sort of time, but actually time must be some sort of special object actually, because it's not just a number, right? Time is not exactly a number. It has some other characteristics that we want, that probably R treats it as something slightly different than a number. Okay, so if it treats it slightly different as a number, it's not exactly a number, then it must have some extra stuff in it. So therefore it's a kind of object. Actually, a number is an object also, but anyway, it must be an object. So systime returns an object of a particular class. All objects are part of a particular class, right? Everyone understand that language? We say all objects are part of a class or instances of a class, right? Does everyone understand that language?
Actually, I don't really understand, Professor.
Oh, okay.
In,
Did you study? You studied Python?
I mean, yeah, but I study like the syntax of it, and not really, like the stuff like what is a class, what is an object.
So you never studied about classes?
No, I haven't, Professor.
Okay. Well, class is a really important concept. So maybe we should take a detour and review what we mean by a class. So let's see. Should we do it in Python? I think we should, since almost everybody has studied Python. But let's just look up a video. Let's see if we can find some video about objects and classes. And let's see if we can find a video. Let's do that in here, YouTube. Or actually, let me do it here. By the way, who won the election? Anybody know?
It's still not conclusive, Professor. They're still counting.
Okay, still counting. Oops, let's go to here. All right, let's go to here and see what we find out. Okay, this is a little bit too long. This is maybe okay. Here's Python, but that's too long. Okay. Let's try one of these. How about this one? All right, let's just see what this one looks like.
I thought that it was going to be so hard and I wouldn't be able to keep up. Before I started with She Codes, I didn't have any coding.
Okay, let's see. So this looks like it's in what language is this? I think this is JavaScript, maybe. But maybe it'll be okay.
So now we know that object-oriented programming is a way or style of doing things. We now need to know what an object is. If you think of real life, the idea that every single thing can be its own object, a person, a house, a car, these in the real world are known as objects. The same applies to a computer program. You can design these objects to hold their own specific information.
So here, you know, if you're designing a web program, you know, like you're designing something on the web, you might want to create a user. I'm sorry, you might want to create a login form. So that might be an object, but or probably anyway. But you're gonna be thinking about your users. You're gonna be thinking about your products. You're gonna be thinking about, I don't know what this is, but some job, right? Does everyone understand? If you're doing that kind of programming, if you're doing some kind of web programming, you're going to have a login form. So you're going to be thinking, you're going to have some users, you're going to have some products, probably, I guess something like this, you'll have some job. So each one of those would be considered an object. So the user would be considered an object. The product would be a product would be a different object.
And these objects to hold their own specific information.
So the user would have, you know, what would you need to know about the user? Well, you might need to know their first name, their last name, their email, and their password. So that's kind of data associated with this user, okay? Or in other words, variables that we need to know about with regard to this user. And here, this would be the product. What might we need to know about the product? Well, we'd need to know maybe the ID and the type, and is it in stock, and its title and its description. So that's data about the product, or variables related to the product. So the product has a title. Maybe the user doesn't really have a title. The product has an in-stock property or an in-stock variable or data about whether it's in stock or not. The user doesn't have that. Okay, so we see that these objects, this is one object, this is a different object, this is one type of object, this is a different type of object. They have different sets of information about that they need to know, or different properties, or different variables. Okay, does this make sense? That makes sense to you?
Yes, Professor.
Okay, so we have that, we have these. I guess job has its own set of stuff, and login form has its own. Like the login form has a username, a password, and whether it was accepted, the login was accepted or not. Okay, so that is
also known as attributes or properties. A glass cup stating whether it's full or empty, a car's mileage. These are known as an object's properties. Not only do these objects contain information, but also certain behaviors. A dog object could bark. An email object could send a message.
Okay, so if you have a user, maybe they could talk, or maybe they could. What else could a user do? A user might purchase something. Okay, so we call that not a property but an action. Okay, so we say that the user has certain properties like their name and their age and their email address, but they also have some actions that they can do. So they might buy something, or they might complain. Maybe they have a complaint action or something like that. So we say that objects have properties and actions. Properties and action. Okay, so here he said a dog might have an action of barking, and what else did he say?
Yes, a dog object could bark. An email object.
So an email object would have certain properties. For example, what? Anybody think of a property of an email? Not an action, but a property.
It contains strings.
Okay, yeah, it would have some string message. And what else? I guess a from and a to, right? Those would be certain properties. But then there might be some actions, and I guess the most obvious one is the send action.
Could send a message. These are actions of an object, also known as methods, that are actually just.
So actions or are functions. So you have a send function, or the dog had a bark function, or what did we say about the what else did we have? I forget. What other actions did we have? Didn't we mention a different action for some other object? What was the other one? I forget. Okay, anyway, we have actions, which are actually just functions. So objects have two things. They have properties or variables and functions. So that's how we often design programs like that. So we say, oh, well, what are the objects involved in this programming problem? Well, we're going to talk about what was that? We're going to talk about cars. Okay, then we have to think about, okay, so what does a car need to do? Now, a car has many, 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 many attributes, right? So many different attributes, but we might not need to be considering all of them for our particular programming task. Like we might just have to do something pretty simple, and so we don't need to know every part in the car and everything. We don't need to know the wheels. Maybe we don't need to know the brand of the wheels or something, who knows? So, but we need to know a certain set of properties, and then we have some actions related to that car. Okay, so the action, I don't know, might be drive or who knows what. So it depends on the project that you're doing. So anyway, we break up the world or our programming task into objects, and then they have properties and they can do things. And the properties are called properties or variables. And the things they can do are called, they're functions, but we don't call them functions. We call them methods, just so that we know that when we use the word method, we're thinking in terms of objects, not just generally about functions. But methods are functions. But when we're talking about them with regard to objects, we call them methods. Again, just so that we know that we're talking about objects, not just generally about functions. Okay, so let's see what he says.
could send a message. These are actions of an object, also known as methods, that are actually just subroutines or functions. Let's see an example on how we would go about making use of an object. In this example, I'm going to be creating a player object. So as you can see, we have created a new file called player.as. But wait, what is this, a class? Why isn't it called an object? This is what we're trying to do after all. Every file we create won't actually be an object, but a class, a blueprint example of the object we want to create. I want to build a house, but first I need plans of the house to understand how it's to be built.
Professor, you are muted.
Okay, so we want to make objects. Like we said, we want to have a dog object. We want to have a, what was it? A dog object, a mail object, a car object, a user object, a product object. We want these objects, but what we do is we make a kind of a blueprint for the user object. So, we say, okay, what do we want a user to have? We want it to have a first name. We want it to have a last name. We want it to have an email. We want it to have a password. And we want it to have some kind of actions also. What would an action be? Maybe purchased. Maybe the user would have a purchase action. So anyway, we put all of this, these specs, these specifications, we put all these specs for what we want a user to be into, we just write them down. And when we write them down, we write them in a certain format so that our code will understand it. And that format is called a class. So the class is just the specifications for the user. And then what we do is we can make many users from that class. So because we already know what it means to be a user, because the class specifies all the things that it has to have, all the instances and methods. I'm sorry, not all the instances, all the properties and methods that it has to have, and then we can just make many because we have the blueprint, or we have the specifications. So we can make user 1, user 2, user 3, user 4, user 100, user 100,000, and so on. So we can have lots of users. So the specification is called the class. And then when we actually make an example of it, like we make user 1, that user 1 is called an object from that class. User 2 would be an object from the user class. User 3 would be an object from the user class. So we have this, the class is just the specification or the blueprint, and then we actually can use then in Python. We can, once we design our class, we design what we want a user to be. We want a user to have a first name. We want a user to have a last name. We want a user to have an email. We want a user to have a password. We want a user to be able to purchase something. We want a user maybe to be able to pay. So once we have the properties and the methods, then we write that as a, it's called, when you write that specification, you say you're writing the class. Once you've done that, then you can create as many users as you want. And they all have, a first name property, a last name property, an email property, a password property, and they all can do those actions. So that is the idea of object style programming. And that's a very popular style of programming. So let's see if we can see in Python. Let's see if we can do a Python example. Python classes and objects. Let's see if we can. It looks a little bit long. Anyway, she's good, but Python classes and objects. Okay, let's look at her. I think she's pretty good. So let's take a look at this as a refresher.
Classes are a fundamental tool in any respectable programming language. Think of a class as a template for creating objects with related data and functions that do interesting things with that data. Python makes it easy to create and use classes. In fact, most other programming languages are quite jealous of Python for its elegance and simplicity. Today we will show you how to use classes in Python, and we will do so in a classy way.
Whoops. What happened?
Suppose we are building a new social network called FriendFace, and our goal is to gather as much personal information as possible about our users.
Okay, so we're going to create we're building a new application called FriendFace. And okay, so people are going to make some comments. It was the best documentary I've ever seen. Post.
For reasons. We will have a lot of data about each user, and we'll write many functions using that data. To organize this effort, let's start by making a class called user. In Python, you define a class by first writing the class keyword followed by the name of the class. It's recommended that
Okay, so what you do is just to write up this specification. Python doesn't, you can't just say, hey, I want to write a class and, it's going to be called user. You can't write it in English, right? You have to write it in some predefined way, right? And that's always true in programming. So this is how you make the class. You have to use the word class with a capital C, and then you want to give it a name. So this class is going to be called the user class. Okay.
define a class by first writing.
And by the way, we're going to learn how to do actually later in our course, we learn how to do this in R, but in R it's not as easy as in Python.
Class keyword followed by the name of the class. It's recommended that you capitalize all the words in the name of your class. Finally, type a colon and press enter. For our first example, we will make the simplest class possible. We will do absolutely nothing. Type pass and press enter.
So
Pass.
Here, she's not going to do, we said you should say what are the properties and what are the methods, but she's not going to do anything. She's just going to make a completely empty class with nothing in it. So she uses this special keyword called pass, and that will just create like a nothing, a class that has no usefulness at all. But she's trying to give us the simplest possible example at first.
Pass is a way to type a line that does nothing. This is necessary because when defining a class, you need at least one line. Now that we have defined our class, we can use it to create different users. To make a user, type in the name of the class followed by parentheses. This looks like you are calling a method, and you are, in fact.
Okay, so to create now an object of this completely useless class called user, this is how you do it, though. This is our, remember what did I say? You can have, I was talking about the example before, right? And you could have one user and a second user and a third user and so on. Well, here, this is how you would do it. So you have the class. If you suppose you normally would put in a lot more stuff than just pass in there, but then to create an example of this class, of this user class, you'd use this syntax. So you just say user, open bracket, and then so you can have user 1, you could have user 2, you could have user 10, and so on. So these would all be instances of the user class, or they would be different users. Okay, now she mentions that this looks like it's a function. When you say user with open bracket and close bracket, you know, the user was a user was what? I can't get rid of this title here, but user was the name of the class, but you can sort of treat it as a function to create the users, the individual users. So this is the syntax for creating a user. She mentions this looks like a function, and she says actually it's a kind of a function, and it's called a constructor because it constructs the individual users, or it constructs the we say the examples or the instances of the class.
Different users. To make a user, type in the name of the class followed by parentheses. This looks like you are calling a method, and you are, in a fashion.
Oh, I'm sorry. She says it's a method. So I think I explained already. What do we mean by method?
A method, basically a function.
Yes, right. A method is a function, and but it's how is it different than just a function?
It is part of a class.
Yeah, that's all. Right. It's just when it's associated with a class, then we give it a special name, just so that we know that we're talking about a function that's associated with a class. Whenever you say method, you know you're talking about classes, not just functions. Okay? So she said this looks like, she actually misuses the word. I don't think we should call this a method. I think we could call it a function. But anyway, I don't know if that's true or not. But okay, let's keep going.
We call user1 an instance of the user class. You can also...
Okay, so we call this thing here an instance of this class. And then I said example of the class, or an instance of the class. So we use the word instance of the class, example of the class, or object from the class. You can use any of those words.
also call user1 an object. To attach data to this object, you first type the name of the object, a dot, the name of the variable, and then give it a value. Let's give user1 a first name.
Okay, now this doesn't make sense because we said pass here. I don't think you can do this. We said pass here, so there's nothing in this class. So there is no first name attribute. So I don't think this makes sense, but anyway, let's see what happens.
Last name. Since first name and last name are attached to an object, we call them fields. They store data specific to user1.
Okay, so I said that we needed to have variables or data or attributes, I called them, and you can also call them fields. So inside the class, we have variables and we have functions. So we call those variables either properties or fields. Properties or fields. And again, we call the functions, we call them methods. So it looks like she's assuming that there's a first name property in here, but you didn't give any property. So I'm not quite sure why she's doing this, but okay.
To see that the data is in the user1 object, let's print them. You access...
Okay, that's interesting. If that works, I had no idea that that would work in Python. I would think that it would just give you an error. But maybe you can define fields so-called on the fly like this. So even though you didn't define it in here, you can just do it here, which is pretty unusual. But Python is somewhat unusual, and it makes things easy, and this certainly would be easy in a certain way. But it seems strange, but I guess it worked.
the data the same way you assigned it. Type the name of the object, dot, then the name of the field.
So the way that you access the properties of this user1 object is you use this dot notation. Okay, so if you want to get the first name property of user1, you type dot first name. Now there was no first name property. So, but I guess when you type this, you create a property inside the class, I guess.
Let's also print the last name. Excellent. By the way, you should not capitalize the name of fields.
Okay, so she says, don't capitalize this first name, don't capitalize this last name. So that's a kind of style, just a style guide. So the style guide was capitalize the name of the class, but don't capitalize the name of the properties.
And if you use more than one word in the field name, separate the words by underscores. This is a tradition in Python, so to avoid uncomfortable stares from your peers, I would recommend using this convention. Here, the name Dave Bowman is attached to the object user1. To make this clear, let's create standalone variables also called first name and last name. These values are not attached to a user object. If we print these values, we get the name Arthur Clark. But if you print the values attached to user1, you get Dave Bowman. Even though we use the same variable names, the values are kept separate. With classes, there is no limit to the number of objects you can make. Let's make a second user, called creatively user2. We will give this user the name Frank Poole. We use the exact same field names as before, but this time the values are attached to user2. To see that Python keeps these three names separate, we will print the three names. So classes are...
Okay, does everyone see? So if you just print first name, last name, that was this. But user1, and then first name, last name, then you get Dave Bowman. But user2, you get Frank Poole. Okay?
used to make objects, and each object can have different values for the same variable names. You can attach additional fields to the objects, and they do not have to be strings. Let's suppose user 1 has an age of 37, an integer. And for user 2, let's assign a value for his favorite book. We are now in a situation where user 1 and user 2 have different fields attached to them. The user...
Okay, now this is so weird. I have no idea that you could do this in Python. So usually you have to list all the fields when you define the class. Remember, we defined the class with pass and so on, and we didn't define any fields. And now she's just defining fields, you know, for outside of the definition of the class. She just says, okay, I want age, and she gives it age. I want favorite book, and she gives that. So now user 1 has an age variable or an age property or an age field, and user 2 has a favorite book. Now I would wonder, does user 1 also have a favorite book? Does user 2 also have an age? I don't know about this.
User 1 has an age, user 2 does not. User 2 has a favorite book, but user 1 does not. If you print the age for user 1, you can see the value is there. And if you look at the type for age, it is indeed an integer. Now look what happens.
So type, well, okay.
When we try to print the age for user 2, which we have not assigned. We get an attribute error. So please, exercise caution. If you are not certain an object has a specific field, you may experience an error. I know what you are thinking. Why did we go through the trouble of creating a class when we could have just as easily stored the data in a dictionary? We will now see the additional features of classes which allow them to transcend a simple dictionary. By adding methods, using object initialization, including help text, we can turn our simple class into a data powerhouse.
Okay, so if you didn't have methods, then if we only had attributes or fields, or we only had variables inside the class, then it's really not any different than what in Python is called a dictionary, right? If you recall what a dictionary is, there would really be no different than a dictionary. But the thing is that classes allow you to also have methods or functions associated with it. So that's why it's more useful or more powerful than a dictionary. If you didn't need the methods, you could just do everything by creating a dictionary instead of a class.
The first feature we will add is an init method. A function inside a class is called a method. Init is short for initialization, and some languages call initialization methods constructors. The name of this method is init with double underscores before and after the method. This method is called every time you create a new instance of the class.
So this is a special, so we said we have to write some methods. So in Python, the way that you write methods is the way you write functions, and that's with the def keyword. So we're going to create a method, a function, but it's going to be inside a class, so it's going to be a method. So, but anyway, the way you still do it is still with the def. Now this there's a special function that you should generally always write, and it's called the init function or the init method. Okay, so you always want to write that when you're defining your class. And here we're defining the user class. So we want to define a init method. And that's called the initialization method. And that's like where you set up certain values for the properties just like as soon as the object is created, it will have a certain set of values. So you usually want, there's usually some certain set of values that you want to start off with. So this is how you can do that. So you define this special method that looks like this, has 2 underscores here and 2 underscores here, and this name init.
The first argument to this method is the word self.
And then you always have to have this keyword as the first argument for the for this init method,
which is a reference to the new object that is being created. You can add additional arguments after self. We'll add full name and birthday arguments. The first thing we will do is store these values.
So far, she's only given the name of the function and its arguments, right? The name and the arguments. So now we want to say we want to give the body of the function now.
Values to fields in the object. We do this by typing self dot the field name and then assign it a value.
So we want to say we want to assign a value to full name. Okay, I'm sorry. No. Sorry, this is a parameter. This is a parameter, and this is the property. So we're going to have a name property. We're going to have a birthday property. But well, let's go on. So anyway, we're going to have a name property, and we're going to get the name property from this parameter. Now, that may not be completely clear yet.
We'll store the full name as a field called name, but we will store the value birthday in a field also called birthday.
So I hate this, but sometimes, well, anyway, this is a little confusing. I don't want to spend too much time doing this right now, but we're just defining this special method called init.
Be careful here. This birthday is the value provided when you create a user object, but this birthday is the field that stores the value.
Okay, so this comes from when you, this is like from this argument, and this is the field in the object. I know this is a little confusing.
To keep this example simple, we will assume the birthday is in year, month, day format. We will now create a user and use the init method. Like before, you type in the name of the class and
Okay, so we're doing the same thing as before, right? User equals user. Everybody follow this so far? Everybody follow this so far? We're creating a user. I think before she called it user 1, but she's not using user 1 this time. But okay, does everyone follow it so far?
Yes.
Everyone follow it?
Yes, Professor.
Okay, now, but we're going to be able to do something a little bit different now. Because we created this init method, and this init method has how many arguments in it?
2.
2. Okay. Who said 2? What's up? Who said 2?
Yeah, I did, Professor.
Okay. He said 2, but
Oh,
I'm
3.
confused.
3.
Oh.
I'm sorry. Yeah.
Oh, okay.
Yeah.
I was going to say, actually, you're right. You're right, sort of, well, okay. 2 or 3. So he said 2, and I thought, yeah, actually, that's right. But this is a third one, right? But this is sort of like, this is sort of not used. So in a sense, there's only 2 parameters here, okay? But of course there are 3, but this one is not really used. But there are these 2. Does everyone understand? There are 2 arguments here. Everyone understand that? 2 arguments here?
Yes, Professor.
Okay. Now, we're going to do what she did before. We're going to create a user, right? We did that before, right? We created user 1, and I think we created user 2, right? But now she's going to create user, an example, we call it an object or an instance. Okay, so we're going to do the same thing, but we can do a little bit more than we could do before. Why? Because we created this new special method, or we wrote this new special method, and it has these 2 arguments. Self is always there. That doesn't really do anything for us, but it has these 2 arguments or parameters, right? So now what we can do is when we create the user, we can just add in an argument here and a second argument. And the first argument can be the full name. And the second argument can be the birthday. And then we will have automatically created a user that has the full name and a birthday. Let's see.
Parentheses. This time, we must provide 2 values, because the init method is expecting 2 values. First the name, then the birthday. You can test that these values are stored in the object by printing them. The data is all there. Let's add another feature to our class. In the init method, let's break apart the name and extract the first and last names. We will call the split method on the full name and pass in a space. This will chop.
Okay, so I don't know if you know, but there's a split method for text in Python. There's a split method for text in Python. And what it allows you to do is split up a string, or split up text or split up a string. So we have some text here, Dave Bowman. And it's stored in full, or it's given to us as the value of a parameter full name. So it's stored in here. So we can take this and we can, I wonder why she didn't use self name here, but anyway, I guess it doesn't matter. Maybe I don't know. Anyway, we can take full name, we can use the split method on it, or I'm sorry, we can split the text, and we're going to split it on the empty space between so we had Dave Bowman, so we're going to split it here, and that's going to go into here.
The name into pieces by cutting whenever it encounters a space. The pieces will be stored in an array. The first name will be the first string in the array, and the last name will be the last string in the array.
Okay. So this is all happening in the init definition, right? This is all part of the init definition,
which we can access using index -1. Notice that we attached the first name to self, but didn't do this with the last name. We'll see what happens as a result. Let's create the user just as before, and then print the full name, first name, last name, and birthday. Run. We get an attribute error when we try to print the last name. This is because we didn't attach last name to the object using self. What happened is we assigned the value to the variable last name, which only exists until the end of the method. This is a quick fix. Let's go back and attach last name to self. Now, if you run the code, everything works as expected.
Okay, anyway, I don't want to spend this is fun, but I think we shouldn't go too long into this. You can watch this yourself, finish it up. But here, now we've done a kind of review of this idea of objects and classes, okay? And how do we access the properties of the user object? How do we access the properties of the user object? How do we access the properties of the user attributes? That's right. How do we access the properties of the user object? How do we access its properties? How do we access the properties or the fields of the user object?
You dot, then
Yeah,
type
right. You use the dot, right? The dot allows you to get the properties or the fields, right? User dot first name, user dot last name, user dot birthday, right? Okay, and I guess we should go a little bit further. We want to see how to do the methods also. How do you access the methods? So right now we only have, I guess, one method here. We wouldn't access that in general, but she might give us another method in the definition of the user class. So we have this one, you generally always need to write it, or even if you don't write it, it's always there.
We can further improve this class by adding some help text. To do this, you type a special string which we call a docstring. This is a string inside triple quotes that you type right after the first line. Now look what happens when you call the help function for this class. Python displays a useful overview of the user class. It displays the docstring as a summary, and it also shows the arguments that are expected in the init method. Even if you are writing code only for yourself, it is a good habit to write a docstring. You may have to use a class years after you wrote it. A few seconds of typing is worth hours of sanity down the line. Also notice that the help call displays two additional items, dict and weakref. We will discuss these in the next video on classes. Let's add another method to the user class that will return the age of the user in years. Like the init method, the first argument is self. And to showcase...
Okay, so now we're going to make a method. Okay, so this is a method too, but this is the init method, so that's kind of different. But generally, we also want to write a method. So we use def because it's actually a function, but it's a function inside the class definition. So we call it a method. But anyway, we use the def keyword, and we're going to call this age, and it's only going to have the parameter self, which sort of means it doesn't really take any parameters, because self is always there and you don't use it. So anyway, let's go on.
Case our responsible nature, add a brief docstring. We will compute the age using the user's birthday, so this method does not require any additional parameters. Since we will be working with dates, we need to import the datetime module. Let's first get today's date. We shall assume it is May 12th, 2001, so that everyone who tests this code will get the same answer. Next, let's convert the birthday string into a date object. There is a way to do this in a single line, but for clarity, we will use a more direct method. In this example, we assumed the birthday was a string in year, month, day format. From this string, we can extract the year, the month, and the day as integers. With these three integers, we can create a date object for the user's birthday. If you compute the difference between today and the birthday, you get a time delta object. The time delta object has a field called days. Ignoring
Okay. So she said if you do today minus DOB, this thing, you get an object. Well, okay, I'm not going to go through that, but she's using the dot. So that's that means that this is a field of something, but let's not go through that right now.
Years, we can now compute the age in years by dividing by 365. Finally, return the age as an integer. To test this method, create the user once more. Then call the age method and print the result. 30 years old.
Okay. All right. So she created a method here called age, and she called it using the dot, just like over here, over where? Remember we said, how do we get the user's, how do we get the user's name? We did user, I forget what we did. But anyway, we used the dot method. So also, if you want to call a method for this class or for this object, you also use the dot syntax, sorry, dot syntax. So it's user dot, and then you mention the method. Okay, that's enough of this. Let's stop. Okay, so now going back to here. So I tried systime. Now systime is actually gives us a this is actually a constructor, or what else did we call it besides a constructor? Well, in Python this might be called an init method. Anyway, so we're calling a constructor and we're getting an object of this type. So here, this is creating an object for us. So end is actually an object. Okay, so systime returns an object of a certain class. Okay, and so it's not just a number. It's an object. So that's why when we did end minus beginning, we got like a whole thing here, right? We didn't just get a number. So because it's an object, it can do sort of different stuff. So it's not just a number. Like I was expecting just to get a number here when I did end minus beginning. Okay, but I got this whole string here and I was puzzled by that. Why did I get a whole string? Where did that come from? Right? I just thought I'd get the difference between these two times. But both of these times are actually objects of a time class. And so it seems like when you subtract them, you get sort of some extra behavior when you do that. Okay, anyway, that was a sort of a long diversion. Because all we were talking about was what? We were only talking about this. Okay, so sorry about that, but that was a long diversion from this code. So anyway, sysdate actually gives us an object of the time class, or a certain time class, and so it looks like this. Okay, anybody have any questions so far? Okay, now in this discussion in this chapter, the only reason we were talking about this is to say that it doesn't take any arguments, or we didn't need to supply with an argument. And here, the mean function, we do need to supply with an argument. Okay, so that was really a diversion or a digression. Okay, so let's keep going. So we know about arguments. What's the difference between a parameter and an argument? What's the difference between a parameter and an argument?
An argument is a specific instance of an parameter.
Argument.
The argument is a specific number that you put in, and the parameter is like the
Right.
concept. I don't know.
Okay, good. All right, let me ask somebody else the same question for a slightly different answer. So how about pratama? Pratama? Okay, how about Huang?
Yes, Professor.
What's the difference between a parameter and an argument?
As it said right there, the parameter is what we put into the function, and the argument is like the whole thing.
Argument is what?
The whole thing? No, not really.
Not exactly. Okay, how about ask Sela? No, Sela's not here. Okay. And how about Putera?
Yes, sir.
What do you, yeah.
For the parameter, it's kind of like a symbol, a representative of what we're gonna put into an argument. The argument is what belong in the parameter.
Yeah, that's a good answer. Right. Okay, but that's a very good answer. Okay, let's ask for another answer. How about Tron? What would you give?
Professor, I think I just answered it.
You just what?
You just call me.
Yeah, I said, what would you say is the difference between a parameter and an argument?
Yes, and I
Oh, I just called you. I'm sorry. Okay. Oh, you didn't have it. Okay, sorry about that. Okay, and how about Tomohiko?
So if you create a function, I think like you have to first define parameter, I guess. So input 1 and input 2, for example, is a parameter.
Right.
And argument, like if you like execute a
Right.
function or use the function, you use argument, you input argument.
That's very
good.
Right. Okay, so both of those the last two answers were, I think, very clear. Okay, let's continue. So we have an idea of the difference between them. And then the argument order. So let's say here we define a function called divid, and it has two parameters. Now, if we call it like this, with 8 and 2, we get 4, but if we call it like this, we get something else. So the order that you enter the parameters makes a difference, right? Does everyone understand that?
Yes, sir.
Okay, but you can also call the parameter, call the function by specifying the parameter names. And then, it doesn't matter what order you put them in. In other words, I could put this second and this first, it would still do the same thing. Okay. Okay, now environments is a kind of advanced topic, but we cover it here anyway. So what, can somebody tell me what this is?
It's the global environment.
Right. And what would you say, what is an environment? If you look in R, sorry, RStudio, you can see here that let's see, what did I do here? I have this, I created this called add them, and then I ran it. And then I created another function called new one. And then we did begin, and we did v equals this. And then there's actually a reference to I here. And then we had end. Yeah. Okay. So, and then if I look over here, this is called the global environment. What do you see in here? What do you see in the global environment?
Is a workspace, I think.
Yeah, it's a workspace, and what's in it?
Let's see all the functions and values that we have created.
Right, exactly. It has all the functions and all the values that we created. That's called an environment. So environment is just like a list of everything you've created. It's just like a piece of paper that has everything that you've created listed on it. Okay, so it's just like a handy list of a handy piece of paper that has all the stuff that you've created. It's right there it's in what we call the environment. So it's basically like a list. In fact, environment may actually be a list. I'm not sure. If we, how can we check that? Where is it? Where is this? Let's say, let's look at it. Okay, let's try question mark. What is it? Global. This thing. Let's see what that says. So the value, here, value. If fun is a function. Okay. It doesn't say, but it might just be a list. Anyway, here it certainly just looks like a list. By the way, I just want to show you something about RStudio here. So suppose, you've written, right here, I've written about 20 lines of code or 19 lines of code, right? But suppose you've written 1,000 lines of code in your program, not just 19. So then, you don't remember what this function was. So you have to go and look for it. Now, one thing you can do is you can use this tool over here. And what this does is shows the document outline. So let's see what happens if I click on that. So here I can see where I defined add them and where I defined new one. So that's useful. You can go and scroll quickly and find the different pieces that you've defined. So like I said, if you have a code that's like 1,000 lines of code, then this is quite handy. Now, another thing you can do is you can go to here, and like in the functions, if you don't remember how they're defined, you can just double click on this function name, or actually just single click on it, sorry. Just single click on it. Let me do that again just to show you. So when I do that, what it's going to do is it's going to add another panel here, or another, not panel, another sheet here. Okay, so let's watch that. Okay, so it created this thing, and it tells me here what add them, how it was defined. And if I do this here, it tells me how new one was defined. So that's pretty handy. And then, if you want to get rid of them, you can get rid of them and go back to the original code. Okay, and then we can also see the values of the different variables that we've created. And v is a vector, and it looks like this. And sum ended up being this. And I and begin end and beginning are these values. Okay, so this global environment panel is useful to have. Now, if you want to get rid of everything, you want to clean up you just want to get rid of all, like suppose you have a whole lot of code and you've run it and you've found some error or something doesn't work the way you wanted, and you want to start from scratch to make sure that your code is self-sufficient. So it like doesn't depend on the fact that you had just run it before. You want to make sure that everything is created properly. So basically, you want to clear out everything that was created, and then just run the code again. It's going to create everything anew, and you want to make sure that everything gets created, and that the fact that you had run something previously and assume that it's currently in your code, you might be making a mistake, right? And you ran a bunch of stuff before and you created some objects. Now you want to make sure that your present code actually creates those objects and doesn't rely on the fact that you'd run it before. So you want to clear out all of the objects that you've created and then see if your code properly creates everything and runs properly, so you can use this thing here. So you can click this. This is going to get rid of everything. So watch. It says, do you really want to get rid of everything? You say yes. Now we can run the code again and everything will get recreated. And then I'll know that I didn't assume that there was stuff in here that it was actually created at some previous time. So let's run it. So we get all the same stuff as before, I guess, nearly everything. Okay, everyone understand this? So this is a useful thing to have. Actually, what does this do? I don't know. Let's try this. Oh. Different display, I guess. Okay. And by the way, if you want to bring in data, this is a good way to bring in data. So you can just, like in R, you can use a function like read.csv, and then here you can see like some of the stuff that you have to include. So you have to include the file name. Okay, let me see what files I have here. Some Excel files maybe here. No, that won't work. Well, anyway, if I had a CSV file in there in my list here, I could go and mention it. Like suppose I had something called whatever, houses. I think you need, I think I need that. Houses.csv. Okay, and then I could import, and I could assign this a value like YYY equals. Okay, and then I'd have the file in YYY. So that's one way to do it. You can that's one way to bring in a data set from your computer, from your hard drive. The other arguments that you might provide is the header. Is there a header in the file? Means, if there's no header, you would want to write false here. If it does contain headers in the CSV file, then you would write true here, but you don't have to write true because this is the default. So it assumes that you have headers. Separators, you can see there's a little comma here. And so it assumes that the separators between your data are commas because it's a CSV file. and that CSV means comma separated values. So that's the assumption is that it's a comma there. So you can see that little comma and the quotes, I don't know. Anyway, so, but anyway, I think it would be just good enough in general, just to give the name of the file. So it might be called houses.csv. And then you could just bring it in, and that would be stored in the variable YYY. Now this isn't going to work because I don't have a file like that. Okay, does everyone understand? But another way is just to click up here and import data, and you could import it from text, or you can use a different, so you can use you can actually, this is another way. Instead of doing read.csv, there's another function that you can use called readr. And I forget the difference. This might be faster or might be able to read more larger files or something like that. I forget the difference. But anyway, you could just use this one. Or if it's an Excel file, I guess you could use this one. So let's try that because I did find an Excel file. What's that? So it says I don't have the capability, I don't have this function, read Excel, in my current R installation. So if I want to be able to use that read Excel, that's what this thing is going to actually use. Not this thing, sorry, this thing is actually going to use, I have to install it. So let's install it. Okay, so now it brings up this interface and I can browse for that file. Okay, here's a file. We'll open it. Okay, so it gives me this stuff, and then I can click import. And gives me error connection in addition to error. I don't know what that error means. Oh, sorry. Oh, sorry, that wasn't an error. Here, it gives me this. Okay, and then it calls another function. Oh, sorry, and it stores. So here's the function that it called, read Excel. So by clicking here, import dataset, actually I could have just typed this out, read Excel and the name of this. Okay, I could have just typed that out, but I did it this way instead. But you could just let's just do it ourselves. Let's just run that again. So I could have typed this out like this, and it will do the same thing. Okay, so now it's all stored in this variable. Okay, so I can take a record of that. And then if I want to view this thing, one command is this, view, like that. And it will open up another panel in here, another file here, like that. So you can view it. Okay. And so as I said, it's stored in this variable. Okay, so that is, one way to use this. By the way, up here, history, this has the list of all the commands I've run today in this session. In fact, actually, it has a lot more than that. I guess it has the entire workspace. So you guys in Swirl, you studied workspaces, right? Right? Everyone studied workspaces?
Yep, I think so.
No? Anybody study workspaces before?
A little bit, Professor.
Was that in Swirl?
Yeah, I think SWOR has a lesson on workspace.
Right, okay, good. So this is all in my workspace. All the commands that I've run are listed in the history here. Okay, so that can be useful. And if you want to, I don't know if you can copy and paste from here, actually. Or you can't. I think you can do, you can push it to the source panel or to the console. So which one is the source panel, by the way? And which is the console? Which is called the source panel and which is called the console? Somebody else. How about Sela?
You are asking about source panel and source code. Yes.
Yeah. Which is the source panel and which is the console?
I'm not really sure. I'm not very good at this coding stuff.
Not very good at what? At the coding? What did you say? Sela?
Yeah, I was saying I'm not very good at R. I haven't.
Well, hopefully at the end of the course you'll be good at R because you'll be doing a lot. Anyway, if you look up here, I'm sorry, here, this thing is called the console. Okay, this thing, where you do things line by line, that's called the console. Okay, and down here, this is when you're doing things, you want to be able to type a whole program here and not have to run it after each line. That's called the source code. Okay, so we have the console up here. This is when you want to do interactive coding. So you just, you want to see one line at a time and see what's happening with it. But usually you don't want to do that. You want to write a lot of code and not run it until you're finished writing it. So then you'll type it down here. Okay, so what is this thing called down here, Stella?
That is the source panel.
Right. Okay. That's the source panel, and this is called the
console.
Console, right.
Yes.
And if I want to take something from the history, here's the history. If I want to take something from the history, and if I want to send it to the source panel, I can click down here where I want to put it. So I can click, say I want to put it here, and I can go to here. This is my the history of everything I've typed, and I can click up here to the console or to the source. So if I want to send it down to the bottom, that's to the source. So I just click and there it is. If I want to send it to here, let's say I want to send this to here, then I would just send it to the console like that. So then, so this is just a way, sometimes this is nice to have the history of everything you've typed right in here. Okay, and you can also find the same history in somewhere. Oh, I think it's in my documents. I think it's this file right here. Okay, so if I right click on this and open it up with something like Notepad++, I think I'll see that same history. Here it is. Sometimes this Notepad++ on this computer, I don't know why, crashes my computer. But here it is. There's a lot of history in here. But let's go down to the end. And I guess we have this. Now I didn't save my workspace yet. So the most recent stuff we did is not in here. Okay, I think. Maybe it is. I don't think so. Okay, so anyway, that file is here, the history file. And that is basically what is in here. Okay, so that's the history. Now the connections, I don't know what it is. And there's nothing there. I guess that's like if you want to read data from some database, you'll have to have connections to some external database. Could be on your computer probably, but still a database. So, but anyway, I've never used that. Now here, these things here, you can use to collapse that. So you can collapse it like this, and here, collapse that. And then this thing, if you want to clean up all of this, like get rid of this, just you don't feel like seeing this part anymore. So I think there's a command which I forget what it is. It's like Control L maybe. So Control L, yeah, that does it. But I also could have just hit this brush up here, and that would, there it is. This brush runs Control L. So you could just clear that. Now you don't want to clear this. This is the stuff that you're writing that you want to, that you kind of want to keep. So you generally would want to just clear that. Okay? But you can press, by the way, this. Now, what does this stand for? The source? Oh, sorry. Well, actually, I don't know what that is. This is what I want. Let's try this. Actually, I don't know what this is either. I thought one of these did one thing, but let me see. Yeah, okay. So this runs the entire page here. Okay, this one here, I believe. Maybe I'm wrong. Let me just try one more thing. No, this runs, rerun the previous code section. What's this do? Ah, this is the one I wanted. This runs everything in here. This runs everything in here. Watch, I'll do it. Okay, how do I know that it ran everything? I don't exactly know, but if I go back to, because it didn't really output anything. So it ran everything, but it didn't output this. Okay, anyway, here you can get plots if you've run some, if you want to create graphs, which makes very good graphs. You'll see them in here. You can export your plots using this and so on. Okay, so I think we're out of time. Actually, we're definitely out of time. Okay, I'll see you next week. We didn't get to answer your question actually, but still you're gonna have more homework for next week. So for next week, did I give you your assignment yet? Anyway, pay attention to Manaba. You're gonna have more homework to do. And I'll try to spend more time answering going over all the practice questions next time. Okay, see you next week.
And Professor, can I ask you something?
Yeah.
I just got the book like yesterday night, so
yeah.
I didn't have time to finish last time's assignment. So
okay, so you can do everything.
The deadline a little bit.
Yeah, because of the difficulty in buying the book. Yes. Oh, and then also, I have to pay you all $10, everybody who bought the book. So you have to send me an email today, please, and tell me, you have to show the purchase, and then, and you're gonna have to buy the book because or you can rent it, because like the second half of the book is not available anywhere except in the book itself. So you're going to need that. So you will have to do it. So you may as well get it now. So anyway, send me the receipt and then also tell me how I can pay you. So I know how to do PayPal, and someone told me that you can do line payment. So I'll do, if you explain to me how to do the line payment, I'll do that, because I have a line account. And if you have any other way that you want to be paid, I'll do that, as long as I can figure out how to do it. Okay, so please do that today. Send me that. Maybe I'll make a homework assignment. I'll make an assignment where you can upload your image and explain how you want to be paid. I'll put that on Manaba so you can do it there. Okay, that's all. Goodbye.
Okay, thank you, Professor.
Thank you, Professor.
See you next time.
You, Professor.